Hello all, good morning. This is Dr. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic one-way ANOVA. And now we are going to see a case study on one-way ANOVA classification. So here we are going to deal with two of the cases. One is coming in the retail marketing and second one is coming in the medicine field. Here we have our students to explain on the topic.
Scenario 1. A retail company wants to compare the effectiveness of three marketing strategies on average weekly sales. Strategy A, social media marketing. Strategy B, email campaigns. Strategy C, in-store promotions. 5 stores tested per strategy.
So here this is our scenario wherein a retail company is going to use three of the strategies. One is the social media marketing, the second one is email campaigns, and the third one is in-store promotions. So here we are going to choose five stores for each of the strategies.
Now the objective. Goal. To determine if there is a significant difference in average weekly sales across the three strategies.
So this is our goal or objective or the hypothesis which we fix for the one-way ANOVA classification. This is our hypothesis wherein we have said that to determine if there is any significant difference between the average weekly sales on the three strategies.
Next, why one-way ANOVA? Used when comparing more than two group means dependent variable is continuous, weekly sales. Independent variable is category sale, marketing strategy.
So why we are using one-way ANOVA classification here? Since we are using one-way ANOVA classification, we are in the purpose of knowing why we are going to use it. The first thing is, when there are more than two groups, we will be implementing one-way classification. So here we have got two or more groups here as discussed, and therefore we are implementing one-way ANOVA. And the second thing is the dependent variable. Dependent variable is nothing but the weekly sales, which means it depends on the strategy we follow, and therefore we mention it as a dependent variable, and that can be put as the weekly sales. And the third thing is the independent variable, which means it is a marketing strategy. Whichever marketing strategy we can also use for the particular sales. This does not depend on any of the other conditions. Therefore, we will make it as independent variable. So these are the three key points to choose a one-way ANOVA classification. Next slide.
Hypothesis. Null hypothesis. All group means are equal. Mu1 equal to mu2 equal to mu3. Alternative hypothesis. At least one group mean is different.
So here we will be fixing the hypothesis for one-way ANOVA classification. The first thing is null hypothesis, and the second thing is alternative hypothesis, as we have got the procedure for the classification process. But here, since we have three major groups, therefore we will be fixing all the means to be equal on the null hypothesis, which is there is no difference. That is what we mention as no difference here, which is mu1 equal to mu2 equal to mu3. And the second one is the alternative hypothesis, which is at least one group is different, which means any of the strategy followed can be applied, or that weekly sales can be increased with the help of the particular strategy. That is what we mention as alternative hypothesis, just complementary to the null hypothesis. Next slide. Steps in one-way ANOVA.
Steps in one-way ANOVA. Collect data, compute groups and the overall means, calculate SSB between group variance, calculate SSW within group variance, compute F ratio, compare with the critical F value or use P value.
So these are the procedures which we follow in classifying one-way analysis of variance, wherein we will be finding all the required values for the final ANOVA table. So these are the things which I have discussed earlier in the procedure itself. Next slide. So out of which, in this particular example, we are going to choose the F value, which is to be 5.2, and the P value is 0.015, wherein the result, what we infer in this result as P is less than 0.05. Therefore, what we will do is, we will reject this particular null hypothesis H0. So what is our null hypothesis? Null hypothesis is there is no difference between the three strategies followed. But here we are going to reject H0. Rejection means we are rejecting the null hypothesis, and therefore we can accept the alternative hypothesis. What is our alternative hypothesis? The strategy followed does have a significant difference on the weekly sales. So conclusion comes under this stage. Is at least one strategy differs significantly, which means any of the strategies followed will increase the weekly sales as prompted earlier. So this is what the first scenario goes.
Okay. Now we are going to summarize it. One-way ANOVA compares means across greater than two groups, helps identify impactful strategies, and it enables data-driven decision making in marketing, medicine, and education, etc.
So this is a summary of the first scenario, and wherein we have learnt all the discussed points. We are moving on to scenario 2, which is coming under medical medicine field, which will be explained by.
Scenario overview, context. In a hospital content, we are studying to the compare to the pain relief effective of the three drugs. The drugs A, prophylactic, drugs B, paracetamol, drugs 3, naproxen. Each drug is tested on the 10 post-operatives parent.
Okay, here we have a scenario that the post-operative patients are treated with these three painkillers. The first painkiller is ibuprofen, second painkiller is paracetamol, and the third painkiller is naproxen. So in a hospital, we are going to check for the effectiveness of three medicines. Since we have discussed earlier about the one-way ANOVA classification, since we have three major groups here, we will implementing one-way ANOVA classification here. Next slide.
Objectives and goals to determine if there is a significance difference in the advantage pain relief among the three drugs.
Average pain relief. So we are going to determine whether there is any significant difference between the painkillers in the painkillers effectiveness. Okay. Third.
Comparative painkillers effectiveness. Why the one-way?
So we have already discussed this. Why we are using one-way ANOVA classification when we are comparing three or more groups. One is a dependent variable, here it is continuous, which is our pain score, and the third one is the independent variable, which is our drug type. Next slide.
Hypothesis, null hypothesis. Mu1 equal to mu2 equal to mu3. All drugs have equal advantage effectiveness.
Average effectiveness.
Average effectiveness.
So null hypothesis is there is no difference, wherein we will be saying that all the three drugs have the same effectiveness. Alternative hypothesis.
At least one drug is different in average effectiveness.
So this is what we have done in the previous scenario also. Next slide. So this is our methodology, wherein we are going to administer each drug to 10 patients. The painkillers are given to 10 patients, each of the painkillers. Measure pain scores after 6 hours, we are going to measure it, and we are going to compare the ratio of the one-way classification using all the parameters required. Next slide. So and the result will be, which is the acceptance value is less than 0.05%, and therefore we will reject the H0, which means we will be accepting the alternative hypothesis. Therefore, what we can say, there is some difference between the effectiveness of the painkillers given. So that is what we infer from this, and therefore we have concluded that at least one drug is significantly different in the pain relief. So this is what we have concluded, and this is our case study regarding one-way ANOVA classification on the retail marketing stage. The first scenario and the second scenario is the medicinal field. So thank you.